This simple NFT contract is just for creating NFTs. Using this NFTFlex, we are going to rent NFT, start renting, end renting, withdraw. All those logic will be handled by this contract. Okay, we don't need this. We just made it for an example purpose. But we are going to make a struct. If you don't know what is struct, it is kind of like TypeScript interface. We are going to make a structure. By using this structure, we are going to save all of our rentals. First one will be address, NFT address. We are going to save this NFT address so that we can make sure which NFT is being rented. Now the second thing we are going to need is token ID. UN256, this is type of integer variable, token ID. Now the next variable is going to be address owner, who is the owner of this NFT. Okay, then the next parameter will be renter. This is also address type. I actually like Solidity because this type safety very much supported in Solidity. By using this, there are less chance you can make errors. Event 256 start time. Then we are going to have end time. Event 256 end time. Now the next parameter will be price per hour. This is also type of integer. UN256 price per hour. Okay, the next parameter will be a boolean. BOOL is fractional. Okay, and next parameter will be address. This is collateral token. Token, it is already suggesting me, therefore I'm just auto completing. UNT 256, this is going to be collateral amount, and last one is boolean is active. Actually it is not is active, is going to be pending withdrawal. You cannot end the rental until the owner of NFT withdraw his money. Therefore we are just going to make it false initially. Once withdraw is successful, then we can end the rental. Okay, and I guess I didn't make this mapping, but I am going to make it since it is going to be essential in this project. One more variable we are going to create, that is UNT 256, then public. This is not a public variable, actually we are going to use it only here, therefore we are just going to make it like this. S stands for, it is a state variable, therefore we are just starting with S. Rental counter, how many rental is been given, this is how we are going to track. Okay, using this variable. Now we are going to create a function to create rental. Okay, function create rental. Here this function is going to be external and address underscore NFT. I am just making this function parameter with all start with underscore, therefore you cannot be conflicted with this struct variables, that is NFT address. But in the function it start with underscore NFT address. Okay, the next variable will be UN256 underscore token ID, and next one is UN256 whenever someone create a rental, they must provide those value. Okay, underscore price per hour, price per hour. Okay, the next variable is boolean, comma, this underscore is fractional. Actually, to make sure you can see this properly, I'm just doing like this. Okay, there is nothing wrong with it, you can do as well. Now we are going to add another variable, address. This address is type of collateral token. This collateral token is type of address, and then again we need another variable or another parameter. This is underscore collateral amount. Okay, now let's do the check. Actually, first of all, we are going to make sure who is the owner of the NFT. If whoever trying to create the rental is not the owner of NFT, then we are going to create an error and show him. We are not going to let him create the rental. Okay, so let's do it. If therefore I am going to use IERC 721 from Open Zeppelin underscore NFT address. This has a function owner of. Okay, owner of underscore token ID. This token ID is not equal to message.sender. If this happen, we are going to revert with something. Revert, once someone reach in this revert, they are not going to get into here. Okay, after this revert, I am going to create an error. This error name will be NFTFlex underscore sender is not owner of the NFT. This is the error we must create at the top. Okay, so let's create this error. Before this, let me create this error. Okay, this is the error we have used. Actually, let's take this error below this struct and this variable. Okay, let's use it here, and you can see this one is not imported. Therefore, I'm going to import it at the top. Import IERC 720 on from @open Zeppelin contracts token ERC 720 on IERC 720 on .sol. I guess this URL is correct. However, you can pause and write it by yourself. I guess we need to provide value for rental counter. Let's make it 0. Let's make it 0. Okay, now we are going to check for another thing, that is we must check that price per hour is not 0. So let's try it. Underscore price per hour is equal 0. If price per hour is equal or less than 0, then we are going to provide this error. Okay, revert NFTFlex underscore. This should be a double underscore. This is the convention I use. You can do whatever you like, but in my case I'm going to keep it like this. Okay, then we are going to say price must be greater than 0, as we are getting the suggestion. Okay, now let's continue. The problem here is this greater than expression must be before this equal sign. Then we are going to create this error at the top here, error, and this is the error. Okay, now here we are going to create a variable we are just going to extract the rental ID UN256 rental ID. We are going to extract that rental ID from here. I think this shouldn't be plus plus. Instead, let's make it 1. Okay, let's make it on. And in here, I'm just going to make it in here. Let's create a rental. In order to create a rental, we just need to create a map. So below this rental, we are going to create a map. Okay, let's make it below here. Mapping. The key map is same as object in JavaScript. Here the key is going to be type of UNT256 and the value is going to be type of rental. And this is a private map, so I'm just going to keep it private, and the name of the something like variable is like s_rental. Okay, let's keep it public. Okay, now we are going to use it in here to save our rental. Here s_rental, every rental will have a key of rental ID, and this is a new rental we are going to create with type of rental, which we have created as a struct up here. This rental type, we are just going to create that rental. Okay, first of all will be NFT address. This is this NFT address we are going to get from that parameter up here in the function. Below here, NFT address will have token ID. The same goes for NFT. Then below here we need owner. This owner is going to be message dot sender. The message dot sender, whoever calling this function is the owner of this rental. Okay, in rental we need to provide renter. The renter, initially it is going to be address of 0. Then we are going to have a start time. Initially we are going to keep it 0, but we are going to change it later. Same goes for end time. It is also initially going to be 0. Now the price per hour. Price per hour, we are already getting the parameter in here. We are going to use that for price per hour. Next we'll have is fractional, collateral token, collateral amount, and pending withdrawal. Let me autocomplete it, because this thing is very easy. You can write it by yourself. At the end, rental counter is incrementing by 1. This is 1. Once we create a rental successfully, then this is going to be 2. Okay, save it. Save it and compile it. APE compile. Press enter. It will compile successfully. The contract is compiling successfully. If anything went wrong, let me know in the comment. Otherwise, you can copy my code from GitHub. I have added the link of the source code in the description of this video. You can reach me in the Twitter or LinkedIn. Whenever you need help, let me know. I'll try my best to help you.